said I like the fit.
Of course. Alright, you got everybody. Thomas, shut the door for me, please. Yeah. Thank you very much.
Do we need to turn our warm-ups in?
Yes, it is Friday. Warm-ups are due. My gift to you is that there is no reflection this week.
But there's homework.
So, today, it's the 4th of October. Yesterday was the 3rd.
Wait, is
That's what I told him. He asked what the date was, and I said, what? It's October the 3rd.
it 6?
All right. It is officially Spooktober, which means by law I'm required to scare you. Okay? It's the law.
Can we play Spooky Scary Skeletons?
Okay? No, we're not going to do that because it's a dead meme. We don't do dead memes in here. But yes, I am legally required to scare you by law. You have been warned.
What law says that?
The law. So.
Are you the law?
The law. So turn in your all the stuff you've done this week, if you haven't already, because it's Friday. And again, my present to you for homecoming is that you do not have a reflection due this weekend. None of you guys are going to remember anything, I'm sure, right? So, okay. So that's the deal. Today we're going to do a little intro to transversal and corresponding angles and all that good crap. It's just a little intro, so there are no notes. Notes will be official on Monday. Some of you were wondering where I was yesterday, which I find interesting, because I've said it multiple times. I had a funeral to go to. It was all good. I'm very good at funerals. I feel like it's one of my best abilities, actually. I'm very good at it.
Is that a good
The person they put in the ground, very down-to-earth lady. So it worked out well.
Oh, I get it.
Hey.
Sir, do you want to sign this?
Yeah, I'll sign it. Why are you leaving me? Oh, wait, no, it's this thing. Okay, so this is the absolute last step. I will sign this when you are done.
Are you gonna broadcast the football game tonight?
No, I'm not doing that, but it is football today. Football! Woo! Football! Homecoming! Football! Yeah!
That's not fun.
Yeah! All right. But no, I'm not going to do the thing because I have to actually travel. My sister had that baby, right, which I still have not seen. And so I'm supposed to go see that 2 hours south, right? I haven't like seen the baby like without like blood all over it and stuff, like so I'm trying to be a good uncle or something. So I got to go visit her this weekend. It's a shame that this is the same weekend you guys have homecoming. Couldn't go last weekend this year, so going now. So yeah, you've been warned. Today we're talking about corresponding angles, but before we can get into that, we have to talk about transversals and all that stuff. So first off, let's talk about what a transversal is, which sounds like a wrestling move, but it ain't. Here's what a transversal looks like. Okay, check it out. We have 3 lines here. The red one I'm calling your attention to. I called that line T for transversal. So what a transversal is when a line intersects 2 other lines. In this case it does. Not always, but in this case it does. Most cases it will. So we have 2 lines, a black line and another black line, and this red line, the transversal that I'm drawing your attention to, hits them twice, right? Once there and once there. So we have 2 points of intersection. Now, what happens when you have a transversal intersecting 2 other lines is you create a bunch of angles. In fact, you create 8 different angles. So we've got angle 1, angle 2, 3, 4. Let's call this 5 and 6 and 7 and 8. It's annoying me to look at it like that, but it's what we're going to call it. You'll notice that we have angles that are kind of in the same relative position. So when we have an intersection, we have a top left, top right, bottom left, bottom right corners, right? Those are the 4 angles that are created by a single intersection of 2 lines. Same thing down here, top left, top right, bottom left, bottom right. When angles are in the same relative position, not the exact same position, but relatively in the same spot, like both are in the top left here and here for 1 and 2, then these angles are said to be corresponding. And no one ever remembers what to call them, okay? But corresponding is what we call those. They're corresponding because they're in the same relative spot. They're both in the top left corner. Another set of corresponding angles, because you asked, is 6 and 8. They're both in the bottom right. So they're going to be corresponding as well. So corresponding angles, here's the definition. You know them when you see them, right? It says, the angles which occupy the same relative position at each intersection where a line crosses 2 others. And we know when a line crosses 2 others, we call it a transversal, right? So if you have a transversal, you're going to have corresponding angles. That's it, right? 1 and 2, 3 and 4, 5 and 7, 6 and 8 are all corresponding angles to one another. Now again, I emphasize relative position because remember, if you're in the same position, that's going to be messy. That's when teleportation goes wrong, right? So you guys in the front row are in the same relative position. You're on the front row, right? Relative to one another. You are not in the same position because you would be in the exact same spot, and that never, ever happens, ever. except in some cases. In order to help you remember corresponding angles postulate, which says if two parallel lines are cut by a transversal, so notice these are not parallel, right? Right, so that wouldn't apply here. But when we do have the magic happen where we have two parallel lines being cut by a transversal, okay, corresponding angles postulate takes place. If two parallel lines are cut by a transversal, they are here. They are not here, but they are here. Then the resulting corresponding angles are congruent. So this tells us that the corresponding angles will be congruent if these guys are parallel. So check it out. They are parallel. 1 and 5 are corresponding because they're both in the top left corner of the intersection, right? Therefore, by corresponding angles postulate, also known as CAP, those two are going to be congruent. We also know that 3 and 7 are congruent because they're corresponding angles. 4 and 8 are corresponding. 2 and 6 are corresponding, so they are congruent. Now again, this only happens, okay, when these guys are parallel. Otherwise, they're not going to be congruent. Look at angle 1 and angle 2. They congruent? No way, right? No way. But they are here. And that makes sense. Now, can we prove this? No, that's why it's a postulate. Actually, last year when I was teaching this, I was going through and trying to figure out how I could prove this to the kids. I was like, man, this is really hard, right? Why is this so hard? And it turns out it's a postulate. That's why it can't be proven. But it has to be, right? These guys are parallel, so therefore they're going in the same direction. If they're going in the same direction, then angle 1 and angle 5 should be the same angle, right? They're taking off in the same way. That seems like what angles do, right? At least congruent ones. So what I'm going to do to help you remember corresponding angles and remember the theorem that, or I'm sorry, postulate that goes with them, corresponding angle postulate. I'm going to show you a little video, okay? I was going to just tell you about the 90s, but you weren't there. And really you have to see it to know it. So the best example I can think of is a commercial from the 90s. You know what Capri Sun is, right? Yeah. Okay, wonderful. All right, so this is a Capri Sun commercial, or at least something like it. It's a little humorous. I'm going to show you it. It's going to get you a real feel for the 90s, okay? So I want you to pay lots of attention. Would you mind hitting the lights?
I never. The graphics are horrible.
Oh, there we go. Infinity.
I didn't drink Capri Sun because I didn't know how to put the
Adam
stuff in
Nagy.
the drink.
Adam Nagy.
It's pretty neat.
I just felt the
There we go.
to the bottom.
Yikes.
Yeah.
Okay, here we go. So it says every 90s commercial ever. Really, it's just the Capri Sun that they're making fun of. Right. This is really true, though. So what's going to happen, like in a regular like Capri Sun commercial, what happens is they drink the Capri Sun, and they like turn into the Capri Sun, right? And they like float around, and they're all like in space and doing cool stuff, and it's like sports, yeah, right? Which I felt was appropriate for today. Football, woo, football.
Respect the house.
Oh, pause. That is not how it's supposed to sound. Let me unplug my sound card and replug it back in. Buy me a new one, please. I'm poor. I'm not joking.
Respect the pouch.
That's right. Respect it.
Guys, Cody and the gang are at the park playing football with down Darius Jackson.
Let's go! You're not going anywhere without your big game liquid slam.
Excellent!
Go long. This one's going downtown. Whoa!
Whoa! Now I got a full team. Yeah! Yeah!
Liquid slam.
Liquid slam!
Oh! Jesus Christ!
We gotta go! Out back! Out back!
Come on!
Why does this bring me joy?
Tough day, kids? Well, I've got just the thing. How about some big game pizza pigskin? Awesome!
Yeah!
Hungry got me in a grapple. Big game pizza pigskin is my hunger that you tackle. All day, every day, big
Touchdown,
game.
Mrs. D.
Big game pizza pigskins for your taste, but the touchdown.
Sack your hunger with Big Game Pizza Pigskins. Pizza that tastes better on a football.
Always use your flamethrower with adult supervision.
Football, woo!
Was that a commercial?
All right, they the uncensored version. We also have the
Bro, play the uncensored version,
Uncensored,
please.
please.
And then
Uncensored,
something with
please.
Jimmy Kimmel, which is the
I'll
least
buy
funny
that.
of all the Jimmys. Let's be honest.
Uncensored, please.
Uncensored.
I'll buy
No.
a card if you want to see uncensored version.
All right, so wow.
Infinity.
What's going on?
Kids,
Where the hell do you think you're
It's a
going?
copy of this. All right, that's not what she said. All right, so oh, you mean the uncensored version? That'll be like the one
That's
change.
not good.
That was moderately funny. I will allow it. All right, so anyway, the reason I showed you that is because, one, psychological scarring is a valid form of education. Now remember, the kid, after he died, all that was left of him was his cap, corresponding Engel's postulate, if you will. Also, we're talking about relative position. Relative position, and it is red, isn't it? Corresponding Engel's postulate. Postulates are always red when I do my notes. His cap was red. It's a postulate, not a theorem. You can't prove it. And then also, it talks about relative position. Remember, if you were in the exact same position as somebody, then that could happen. That would not be good, right? You want to be in the same relative position. That's what that means. They're both in the top left corner. They're not in the exact same spot because that would get messy. Welcome to October. You've been warned. You have been warned. Nope. Too much happiness in here. So here's what we're going to do. Take out a piece of paper. YouTube, this is what I do. I'm telling them. I'm going to distract them with one thing over here, and I'm going to then later do a trick here, and they're going to miss it. And I'm going to tell them that I'm going to do that, but they're still going to miss it because they're all freaking morons, okay? Freaking bats. It's freaking bats. Freaking bats. All right, nerds, let's go.
Beat it, nerd. Beat it, nerd. Except none of us are here nerds.
It's freaking bats. You're all in math class. You're all nerds by definition.
Except for you. Okay. No, no proof.
That's weird. I don't want it. Somebody take it. Thank you.
Hey, what's this made out of? Huh? Is this wood? No, wood.
You see,
That was made of like bamboo or something. That's hard.
Bohemia, Czechoslovakia. Very cool. Here.
No, I want to use that one. That's cool.
Don't break it, Schlaffer. Mucho cuidado, por favor. All right, so we're going to prove that angle 1 and angle 2 are supplementary. Now, the beauty of this is that we don't even care about stuff down here, right? Because that's 5, 6, 7, 8. We only care about 1 and 2. There's two things that they give you here. You might think it's only one, but there's actually two things. One, they tell you L and M are parallel, okay, which is useful. We're not going to need that because we don't care about M or anything down there, right? What we do care about is that L is a line. Now, whenever we use a lowercase cursive letter, that implies line. And the reason for that is because it would be really annoying to write this line symbol. I hate the line symbol, don't you? Like, I can write segment and do a little line above it, and it's like, that's fine, that's great. But as soon as I have to draw those arrowheads on there, it's like, oh my god, it looks awful every time. And so mathematicians are just like, why do that? So what we're going to do is we're going to use lowercase cursive letters to mean lines. So when I see a lowercase cursive letter all on its own, I know we're talking about a line. Capital cursive letters are planes. Remember that one, right? We did that at the beginning of the year. So though that is a line. And that's what we're going to use. So we're going to say given, when we do this proof, that L is a line. Because we are. It's just kind of hidden, right? So now that we know that L is a line, what does that tell us about angle 1 and angle 2? Because again, that's what we want to talk about, right? They're a linear pair, because there's two of them, right? Two angles on a line, they're a linear pair. So because L is a line, then angle 2 and angle 1 are a linear pair. So let's write that down. Angle 1 and angle 2 are a linear pair by definition. So I'm just writing this out instead of doing a box proof like left side, right side thing. It's the same dumb crap, right? Given that L is a line, therefore angle 1 and angle 2 are a linear pair by definition. You can throw a therefore symbol if you want. By definition is my reason. What I'm stating is that they're a linear pair. Are a linear pair. Oh, gross. Linear pair. Most disgusting thing I've seen all day. Linear pair. By definition. Cool. Now, our last step should inform our next step, right? So they're a linear pair. So what? What does that mean? They equal what? They equal 180. We can't jump there yet because there's a theorem that says they are something else. But it basically means the same thing. They're supplementary. What's the theorem that says linear pairs are supplementary? What do we call that theorem? Oh, come on. Take a guess.
What?
LPT, which stands for what? Linear pair theorem, right? So linear pair theorem says if something's a linear pair, then blah, 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 right? Well, is this a linear pair? Yes, we've established that. So now we can say blah, 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 blah. What does linear pair theorem say? What is the blah, 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 blah? That's a supplementary, right? So let's write that. So by linear pair theorem, again, I can write it in any order I want. I'm going to give my reasoning first. By LPT, I just feel like it flows better. Angle 1 and angle 2 are supplementary. Now, I know you want to just write the equal 180, but we can't skip that step yet. Not yet. Okay? Someday we'll be able to skip right to it. Angle 1 and angle 2 are supplementary. Let's do SUPP. SUPP. Sounds like a Frenchman in a bathroom that I don't want near me. All right.
Why don't you want him near you?
SUPP. And I go. Right?
SU stands for.
And that's why we don't use urinals. All right, so angle 1 and 2 in supplementary by linear pair theorem. Now, isn't that what we wanted to prove?
No.
We're done! Ta-da! We did it! Hooray! Swag box.
Swaggiest of all.
The swaggiest of the boxes. All right, so 1 and 2 are supplementary. We did it. That was it. That was the proof. They're on a line, which means they're linear pair, which means linear pair theorem says they're not congruent, supplementary. That's it. Again, ask yourself, so what after you write a step, right? It's a line, so what does that mean? Well, if it's a line, then angle 1 and 2 are on that line. Means they're a linear pair, by definition, right? There they are, right? 2 of them on a line. What does that mean? Well, linear pair theorem says that they must be supplementary. We're done. That's it. That's all it is, man. I do?
Yeah, it's crazy.
Oh, my bad. All right, so
It's not an insult.
angle 1 and angle 3, we're going to prove that they're congruent next. So now, instead of proving that 1 and 2 are supplementary, we already did that. We're going to prove 1 and 3 are congruent. Now, there's a shortcut to this, which we're not allowed to use until next week. It's called vertical angles theorem. Remember that one, scissor theorem? Your words, not mine. Right? Remember this? Right? So it means that these two angles are going to be congruent by vertical angles theorem. Right? Now, it's a theorem, so there should be a way to prove that. And that's what we're going to do. Right? Because we're not allowed to use vertical angles theorem yet. We're going to work our way through it. So my hint to you, 1 and 2 we've just proved are supplementary. Right? What do we know about 2 and 3? By the same dumb logic, right? Because this is a line, T is a line, right? And they're sitting on it, and there's 2 of them, so they're vertical, linear pair, right? And then by linear pair, they're supplementary. So I'm going to say by the same dumb logic. Got it? By the same dumb logic, angle 2 and angle 3 are supplementary. Have to be, right? They're both on a line, they're a linear pair, therefore linear pair theorem, right? The same dumb crap applies to them as 1 and 2 does. Now, why did I bring up 2 and 3? Well, my goal now, right, my new proof that I'm doing, I'm putting it all in one, that way we don't have to write it twice. We have a short class today. My new thing I want to prove is that angle 1 and angle 3 are congruent. So I need something with angle 1 and angle 3 together, right? Well, right now I've got angle 1 and angle 2, something about them, right? And I've got something about 2 and 3. So how do I get 1 and 3 together is my goal. First thing we should ask is, okay, so what? So what if angle 1 and angle 2 are supplementary? So what if angle 2 and angle 3 are supplementary? What does that mean? They add up to 180 by definition, right? So now we can write that thing that you guys wanted to write. Measure of angle 1. So by definition, I'm going to write my reason first just because I feel it flows better. By def, measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 2 plus measure of angle 3 equals 180. Right? That's the definition of supplementary. It's the next logical step. If I know the supplementary, then I also know this. So I've got 2 equations, one with 1 and 2 in it, another with 2 and 3 in it. I want to get 1 and 3 in the same room. Remember, if they're really meant to be together, the math will take care of the rest. Right? So we just got to get in the same room. So how do we get in the same room? What do you notice?
Subtract.
Not yet. Substitute. Right? See how angle 1 and angle 2 equal 180? Well, I know that 180 is the same thing as this crap. So these guys are interchangeable, right? If that equals 180 and that is 180, those equal that, right? So I can switch them out. Think about it this way. If I tell you 3 plus 5 equals 8, instead of saying the number 8, couldn't you just say 3 plus 5? How old are you? I'm 3 plus 5, right? And you would know 8 years old, 8 and a half. Okay. Same dumb crap, we switch them out. So I'm going to write that. By substitution, SUBS, I can switch out those two guys, right? I'm allowed to do that. Angle 1 plus angle 2. You need to write M for measure, okay? Don't just write angle 1, angle 2. The measure is going to equal the measures of the others. Right, instead of writing 180 here, all I'm doing is writing measure of angle 1 and angle 3 because it's the same dumb crap, which means they're interchangeable, right? Like the sub you had the other day. We're both teachers. We're pretty much the same, right? We speak no evil, okay? I heard things went not bad, so there's that. I know. So here we are, okay? So, here we are now. Okay? So 1 and 3 are in the same room, but there's extra people there. We got to get them alone. Okay? Is there a way to do that? Will the math take care of it? Yes. What are we going to do? We're going to subtract, right? So by subtraction property, right, SUBT, then we know that angle 1 is equal to angle 3, because what did we do? We subtracted angle 2 from both sides, right? That's going to make it go away. Therefore, angle 1 congruent to angle 3. That's our last step. Swag. How you like them apples? Feeling decent? Yeah. Do you see the logical argument? Let's start from the beginning. It says angle 1 and 2 are linear pair by definition. Of course they are, because they're on a frickin' line. Then it says by linear pair theorem, and of course I'm allowed to use that because they're a linear pair. Then they're supplementary. Then I write that same dumb crap for 2 and 3, right? So I know 1 and 2 are supplementary, 2 and 3 are supplementary by the same dumb logic. Okay? By definition, they add up to 180. How do I know that? Because it says they're supplementary. Do you see how the last step informs the next step? Now that I have this, I know that they equal each other. How do I know that? Because, well, this equals 180 and that equals 180, so they equal each other. Math. It's frickin' bats. Frickin' bats.
Why do you keep saying that?
It's a theme.
It's October.
October.
Do you not know that? Caleb. No, I don't.
It's frickin' bats.
My dad on Halloween had us in the police station.
Are you pulling it up? The girl that says I still like
My dad.
Uncut, uncensored.
My dad on Halloween dresses up as a ghost.
Caleb, hey, pets.
I can't see him.
Look at it's freaking bats. I love Halloween. Look,
Why do you like Halloween so much?
it's always Halloween in my soul.
Oh.
Thing ever.
Whoa.
Is that Papa?
Look at the dad.
Papa, what are you doing in my geometry class?
It's frickin' bats. I love Halloween. All right. So, next thing I want to do, just for funsies, using this idea, okay, all that we're given. What I want to do is I want to prove that 1 and 5 are congruent. How would I do that? They're corresponding angles, right? Cap. Remember the red cap? That's it. That's a really easy proof. So the next thing I want to do is prove 1 and 5 are congruent. Well, that's very easy. So given that L is parallel to M, and I need to be given that, because if L and M aren't parallel, are corresponding angles always going to be congruent? No, because they can look ugly, like this, right? 1 and 2 are an example of corresponding angles. But they ain't congruent. Why? Because these two lines are not parallel, right? But because they are, which I'm given, then I know that 1 and 5 must be congruent by cap. What is cap again? What does it stand for? Yep. So by corresponding angles postulate, that's the P in cap, right? Angle 1 is congruent to angle 5, and we win. Done. Swag box. That was super easy. You could also, if you want to be picky, be like angle 1 and angle 5 are corresponding angles by definition. Therefore, we can use corresponding angles postulate and say they're congruent. Yeah, I'm cutting to the chase here. Okay, being kind today. So next thing I want to do. This is what you're going to do. Prove that 1 and 8 are supplementary. I've given you all the information you need. How can you do it? 1 and 8 supplementary. Go. Do it. If you get it done, great. If you don't get it done, it's homework. And here's the thing. I don't know how much time you have left because the clock is broken. I don't know who broke it, but they did. I deny it.
8 minutes.
That's right. I feel like that was for science, which justifies it.
Does it have to be in like
For science.
math terms, or can it be like?
You need to do a proof. Prove that angle 1 and angle 8 are congruent. Or supplementary.
Should we be in partners?
Yeah, of course, always. It's not about what you do in life, it's about who you do it with.
Be my partner. I'll have to do this for homework. Or hey, how cute!
I literally about to tell you, but I probably sound tired of trying to say it.
It's easy. Yeah, Justice. What do you think? Your Maxie playing?
It's not 4, bud. I know.
I will tell you that. Announcement for you nerds. I've heard that a lot of people can't make game club on Mondays and Tuesdays, so we have switched the Monday date to Friday starting next week. So it's Tuesdays and Fridays now, which is a lot harder to remember. But it is Tuesdays and Fridays. Because apparently you guys would rather be here playing games and doing nerd stuff than going home and like living your lives. So I guess Tuesdays and Fridays from 3 to 5, both days. On occasion we will have pizza, but not until I have money again. Which will not be for a while.
Can we bring snacks?
I get it.
I like
Does that mean the shortest mouth is
Remember I'll put you in the games club. I'm asking. Yep. I'm giving it back to you.
It's frickin' bad. It's frickin' bad.
Andre's behind bars.
Again?
Wow, is that actually a semi-decent joke for you?
It was so cute. I love it.
Big Mac.
Why? Big
Big Mac.
I'll talk to you later about that.
Is that a semi-tolerable joke for you? What?
Whoa, there's a peephole right here.
Oh, that's not a peephole, Slobber.
Brainerd, behave.
Oh, it's a
In the privacy of your own home, Brainerd. In the privacy of your own home.
It's a glory.
Slopper, go find your seat.
Yes, sir.
Thank you.
It really did me back.
Brainerd, what I was trying to say. In the privacy of your own home.
Okay.
Proof 1 and 8 supplementary. How you doing?
I can't blow off my nose. No, people. Hey, there's a lady outside your door. Did you know that?
Oh yeah.
Was that a semi-tolerable joke for you, Mr. Mac? You didn't call me stupid.
Not yet. The day is young.
I just get those nerds out of my sight, man.
Be it, nerd.
That's the joke. Gotta have grape. What a flavor.
Can I have grape fillet?
Anybody have the proof for 1 and 8 being supplementary? Think they have an idea? There's 2 parts that you're going to need. First, you're going to need to establish that 8 is in fact supplementary with something, right? And then you're going to have to figure out how that something is the same as angle 1. See you on Monday. Yep.